The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for the Chapter 11 test. What questions, if any, do you have for me?
So 10, 12, and 14 on 11.7 I struggled with. I couldn't figure those out. So if we could walk through those, that'd be awesome.
All right, let me find the one that is your specific one. There we go. So you said 11.7?
Yeah, the homework from last night. Yeah.
Okay. Numbers 10, 12, and 14. Is that what you need?
Yep.
Okay. So now you should be seeing the WebAssign screen on the left and the whiteboard screen on the right. Is that correct? Is that what you can see?
Yeah.
Super. Things are working wonderfully. Okay. In 2 years, 40% of a radioactive element decays. Find its half-life. All right. So our formula is going to be A equals A sub 0 times 2 to the negative T over H power. Any questions about why I'm using that formula?
No.
Right. Okay. And let's see, we've got T, H, A sub 0, and A. 2 years is the time. The half-life is the unknown. We don't know what the original amount is, so we say it's A sub 0. It says 40% decays. So that means 60% is left. So A, the final amount, is 60% of the starting amount. Are you okay with where I got the 60%?
Yeah.
Okay. So now our equation becomes 0.6 A sub 0 equals A sub 0 times 2 to the negative 2 over H power. We're going to divide both sides by A sub 0. So 0.6 equals 2 to the negative 2 over H power. Now I have it in a form that I can convert into a logarithmic equation rather. So log base 2 of 0.6 equals negative 2 divided by H. Now, we're trying to solve for H, and H is in the denominator. So things get a little trickier here. We're going to multiply both sides by H. So then H log base 2 of 0.6 equals negative 2. Okay. But we're trying to isolate H. So now we're going to divide both sides by log base 2 of 6. So H equals negative 2 over log base 2 of 0.6. I'm going to use the change of base formula. So that becomes negative 2 divided by the quantity log base 10 of 0.6 over log base 10 of 2. Okay. Any questions about any of those steps? So now on my calculator, I'm going to go negative 2 divided by parentheses log of 0.6. I'm going to close the parentheses around the log, around this, I mean. Okay. Then divided by the log of 2. Close the parentheses around that, and then close the parentheses around that whole thing. So I've actually got 3 sets of parentheses. Okay, and I get 2.713. It says round to 1 decimal place, so 2.7 years. Okay with that?
Yep.
All righty. Anybody else, any questions on that one before we go on? Okay, we're going to now look at number 12. So an isotope of lead has a half-life of 8.4 hours. How many hours ago was there 30% more of the substance? Okay, so again, we're going to use the formula A equals A sub 0, 2 to the negative T over H power. And we need time, half-life, A sub 0, and A. An isotope of lead has a half-life of 8.4 hours. How many hours ago, so time is the unknown, was there 30% more of the substance? So we're going backwards in time, okay? So at the end of the problem, we have that much. But let's see, a certain number of hours ago, there was 30% more. So A sub 0 is 130% of A, which is the ending amount. So this is backwards from what we did before. Are you okay with where I got the 130, the 1%, which is 1.3?
Yeah.
All right. Kind of tricky, this one. So A equals 1.3A times 2 to the negative T over 8.4 power. We'll divide both sides by A. So on the left, we get 1 equals 1.3. Actually, what I want to do, I'm going to back up here. I want to divide both sides by 1.3A. So what that gives me on the left is 1 over 1.3, and on the right, 2 to the negative T over 8.4 power. Why did I do that? Because I want to get it in a form where I can go to changing it to a log. All right, now, 1 over 1.3 is not a nice number if I punch that into the calculator, so I'm going to just leave it like it is for now. I suppose I could change it into 10 over 13, getting rid of the decimal if I want. I'm just going to leave it. So this becomes log base 2 of 1 over 1.3 equals negative T over 8.4. All right. Any questions on that step? Changing it from exponential form to logarithmic form. I'm now going to multiply both sides by negative 8.4. So on the right side, the 8.4s and the negatives go. So I have T left on the right side. I'm going to switch that over here. So T equals negative 8.4 log base 2 of 1 over 1.3. Which is negative 8.4. I'm going to use the change of base formula. I used log base 10 of 1 over 1.3 all over log base 10 of 2. Again, any questions there? So negative 8.4 and then log of 1 divided by 1.3, close that up. Divided by the log of 2, close that up, and I get 3.17949, etc. It says round to 1 decimal place, so the 7 would round up 3.2 hours. Okay with that problem?
A quick question, sorry about that. Can you explain again the 1.3, how you got it? I barely got here. I was like, what? How you got that? Can you explain it?
So, in other words, all the way back here, right?
Yeah, sorry about that.
Not a problem. Okay. So this particular problem, which is number 12 in 11.7, is going backwards. We know the final amount. Well, we don't know the final amount, but the final amount we're saying is that, A, okay? How many hours ago was there 30% more of the substance? So going into the past, we had 30% more than what we've got now. All right, right now, we've got 100% of A. In the past, we have 130% of A, which converted to a decimal is 1.3.
Oh, okay. I understand. Thank you.
You bet, I bet. It's a little trickier than the other ones, not quite as straightforward. All right, any other questions before we go on to the next one? Okay, let's take a look at number 14. A sum of $7,000 deposited in an account grows to $11,000 in 6 years. Assuming annual compounding, what interest rate is being paid? Round your answer to 2 decimal places. Okay, the key to this whole thing is right there. Annual compounding. In other words, it's not continuous. So we're going to use this formula. A equals P times 1 plus R over K to the KT power. Okay. P is, let's see, which one are we doing here? We're doing number 14, is $7,000. A, the ending amount is $11,000. Time is 6 years. And the interest rate is the unknown, and K is 1 since it's annual compounded. All right. Any questions about any of those pieces of information? So now filling everything in, we have $11,000 equals $7,000 times 1 plus R, which is the unknown, over 1 to the 1 times 6 power. All right. Now, R over 1 is just R. 1 plus R is 1 plus R, and 1 times 6 is 6. So I can simplify it down to that. Again, any questions how I got there? So now I'm going to divide both sides by $7,000. On the right side, that reduces down to 1. On the left side, that reduces down to 11/7. Okay. So let's go back to chapter, is it chapter 9 or chapter 10, where we take the root of both sides? I can't remember offhand, but what we're going to do now is we're going to take the 6th root. Okay. When we take an even root, there's a plus or minus that gets applied. Okay. So when I've got what? Plus or minus the 6th root of 11 over 7 equals 1 plus R. All right. Subtracting 1 from both sides, I get the following. I get R equals -1 plus or minus the 6th root of 11/7. Okay, you still with me? Let's see here. How do I get the 6th root of 11/7? Well, there's a couple of different ways I can do it. Remember this button that we talked about, the X root button? I could use that. So I could go the 6th root of 11/7. And to do that, you put the 6 in first, or I could take 11/7 raised to the 1/6 power, doing it using exponential notation instead of radical notation. Tell you what, let's do it this first way. Okay, so R equals -1 plus, now using this notation, I put the index in first, so 6, then I go second, the xth root of parentheses 11 divided by 7. When I do that, so the plus, I get 0.078240832. Now I'm going to do the minus. Okay, so that, which gives me negative 2.078240832. Well, okay. Since in this problem, the amount is growing from 7,000 to 11,000, it couldn't have a negative interest rate. It would have to be positive, okay? Otherwise, it would get smaller. But they, let's see here, the answer they want is a percent. So converting this to a percent, I get 7.8240837%, rounding to the nearest tenth, 7.8%. So this goes back to a previous chapter, the whole idea of taking the 6th root of something to get to the base inside. How are we doing?
We're good.
All right. Any other questions from you?
Nope, that's about it.
All right. Anyone else? Any questions?
I just wanted to mention that on my number 12, I also struggled with number 12. And there is a video to watch for number 12, but it was the wrong video. It wasn't related to the problem on number 12.
Huh. The video that's with WebAssign?
Yes.
Okay. Do you want me to go through yours?
No, I figured it out.
Okay. Okay.
I just wanted to mention the video thing.
Yeah. Sorry about that. I can honestly say I've never watched those videos, but they're there for whatever, I guess. Okay. Anybody else? Any specific questions you want to look at? All right, well, let's just run through some highlights from this chapter. And so what I'm going to do now is, hopefully if I can do this correctly. There we go. And so now let's go back to, and now you should just see the whiteboard screen in the normal mode. So chapter 11, let's see, section 11.3. We looked at graphing exponential equations. So they're in the form of y equals b to the x. We said that the base has to be greater than 0 and it can't equal 1. If the base is greater than 1, we get an increasing exponential function. If the base is between 0 and 1, we get a decreasing exponential function. Okay. All of the exponential functions of this type have the following characteristics. The domain is all real numbers. Domain, all real numbers. The range is greater than 0. Let's see, the y-intercept is at 0, 1, and no x-intercepts, okay? If it's this case, it's increasing over its entire domain. If it's this case, it's decreasing over its entire domain. Just like in parabolas, if you have something like this and you have a constant here, that's going to shift it up or down. If you have a number that's part of the exponent, that's going to shift it right or left. Here, a positive moves it up, a negative moves it down. Here, a positive moves it to the left and a negative moves it to the right. Inside inverse, outside obvious, just like with parabolas, quadratic equations. Okay. Let's see here. If you have something like this, let's see, y equals a times b to the x, okay? A is going to be your starting value because at the beginning of time, if this is 0, this is 1, and a times 1 is a. So let's say you've got something like this. Okay, your starting value is going to be 200, okay? Since 2 is larger than 1, it's going to be increasing. If it was, say, 0.2, then it would be decreasing. All right. Let's see here. Compound interest formula was introduced. We looked at one of those here a little while ago. This is when the interest is not continuous. So if it's compounded annually or semi-annually or daily or monthly, it's not continuous, you use this formula, okay? If it is continuous, then you use that formula. As I'm going along, if I'm looking at anything you're like, could you do an example of that again or something, please speak up. Otherwise, I'm just going to kind of do a general review. 11.4, we introduced logarithmic equations. We talked about how if you have something in this form that's a logarithmic equation, you can rewrite it in exponential form. The base stays the same, but the players change places. Okay. Let's see here. Look at there. Yeah, we went back and forth between the two forms. So let's say you've got something like log base 10 of 100 equals 2. In exponential form, that would be 10 squared equals 100. Again, the base stays the same. The players switch places. Notation, log is the same thing as log base 10. Okay, on your calculator, you would use the button that says log to use log base 10. Okay, let's see what else. 11.5 introduces base e. Log base e is the same as ln or natural log. Okay, let's see. This is used when you're dealing with continuous growth or continuous decay, continuous compounding interest. Okay, let's see here. We also had a doubling formula. T equals the natural log of 2 over r. So if you've got something that's growing continuously and you know its growth rate, you can use this formula to find out the time, how long it takes for it to double. You can also do it using this. It just takes longer. Let's see here. Formulas. Okay, so as I mentioned, we've got this one. That's the compound interest formula. Exponential growth or decay formula. doubling time of an exponential growth problem or one that's growing continuously. Let's see here. We've got the change of base formula. Log base b of x equals log base a of x over log base a of b. And then finally, we've got the exponential or radioactive decay formula. A equals a sub 0 times 2 to the negative t over h power. Now, if you want to put these formulas on a note card, you can use those for the test. Okay. But that's all in terms of notes. Any other questions? Any other examples you want me to look at?
Yeah, can we look at number 12, 23, and 34 on chapter 11 review?
Okay, so hang on. Let's see. Court change. Where are we here? Trying to find your, there it is. Okay. You said on the chapter review, right?
Yes. Yes.
Okay. So let me switch back to putting both screens over there. So give me just a minute. Okay. All right. So starting with which ones?
Number 12.
Number 12. That one right there. That the right one? Yesenia? Hello? Yesenia?
It's Laura.
Oh, it's Laura. I'm sorry. Laura?
No
For some
worries.
reason, I thought Yesenia was the one asking the questions. Okay. All right. So in that case, it's not the right one. Sorry. Give me a minute here. Yeah, I can't see everybody's information. Sorry about that. Hang on. We'll get there. Okay, Laura. Here we go. Okay. And this is chapter 11, the review. Sorry about that. And problem number 23 and then 35, etc. Is that right?
34.
So just 34?
12,
Oh, 12.
3, and 34, please.
I got you. Okay. Okay. All right. Here we go. Is that the right number 12?
Yes.
Super. The value in dollars of a certain model car is given by the function V of t equals 18,000 times 10 to the negative 0.135 t power, where t is the number of years from the present. Find the value of the car in 9 years. So basically they want us to find V of 9, which would be 18,000 times 10 to the negative 135 times 9 power. Okay. So I can do one of two things. I can predetermine what that is, or I can write 10 to the power and then parentheses negative 0.135 times 9, close it up. Do you want to predetermine it or do it as it is?
Let's do it as it is.
Do it as it is. Okay. So I should have 18,000 parentheses 10 raised to the parentheses negative 0.135 times 9, close parentheses, and then close parentheses. I get V of 9 equals 1097.166415. And it says to round to the nearest dollar. And let's see, the present value in dollars. So basically this is dollars. So rounding to the nearest dollar would be 1,097, because this would round down, $1,097. Okay with that?
Yes, I just got mixed up when I tried following it through and predetermining it,
Sure.
and I got messed up going that route. But now I repunched it in the calculator and I see I found my error.
Okay, great. So the next one is 23, yes? Did you want to look at 23?
Yes, please.
All right. If $12,300 accumulates interest in an annual interest rate of 9% compounded continuously, how much will be in the account in 60 years? Okay, because it's being compounded continuously, we're going to use the formula A equals P times E to the RT. Okay, not the other formula because it's continuous. So we've got P principal is $12,300. The annual rate is 9% or 0.09. Time is 60 years. So the final amount, A equals 12,300 times E raised to the 0.09 times 60 years. Again, we can predetermine 0.09 times 60 and use that, but we can just put parentheses and a multiplier and do it as it is. 12,300 second E to the 0.09 times 60, close that up. And I get 272,328.919. And that's dollars will round to the nearest cents. So the 9 is going to round up. We're going to get 2,723,298.92. So or 92 cents. Okay with that one?
Yes, I used the wrong formula.
Yeah, be careful with that. Okay, next up is number 34. Yes. You want that one? Or you keep turning it on and then off. Now it's on.
Yes. Sorry.
Okay, just go through the ones that you don't have finished correctly. Okay, the height in inches of a certain plant is approximated by the function h of a equals 14 plus 20.02 natural log of a, where a is its age in years. How tall will it be when it is 26 years old. So basically, h of 26 is 14 plus 20 point, oops, did that wrong. Sorry about that. No, that's what I pin. 0.02 natural log of 26. So that goes into our calculator. 14 plus 20.02 natural log of 26. Close it up. And I get 79.22709,269. It says round to the nearest inch. This would round down, so 79. Oops, inches. All righty. Anybody questions on that one? Okay, and then let's take a look at number 38. We'll do that in just a second here. Are we good to go on? I'll take that as a yes. Number 38, a wooden statue. What? Question?
Wait, never mind.
Oh, okay. All right. A wooden statue found in Egypt has a carbon-14 content that is 4/5 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old is the statue? Round your answer to the nearest 100 years. All right, so we're talking radioactive decay. So A equals A sub 0 times 2 to the negative T over H power. The half-life is 5,700 years. We're trying to find out how old it is, so time is the unknown. Now, once again, they don't, let's see, they don't give us the starting or the ending amount, but they do say, says, a wooden statue found in Egypt has 4/5 of that found in living material. So the final amount is 4/5 of the starting amount, okay? 4/5 would be 80%, so you could also write that as 0.8 times A sub 0, if you wanted to do it that way, either 4/5 or 0.8. All right, so I'll go with a 0.8. So 0.8 A sub 0 equals A sub 0 times 2 to the negative T over 5,700 power. Divide both sides by A sub 0. 0.8 equals 2 to the negative T over 5,700 power. I can now change this into log base 2 of 0.8 equals negative T over 5,700. Multiply both sides by negative 5,700. On the right side, the 5,700s go and the double negative goes. So I have T on the right side. I'm going to write that over on the left side now. So T equals negative 5,700. I'm going to go ahead and use the change of base formula right away. And that will take me to my answer. So I'm going to have negative 5,700 log of 0.8, close it up, divided by log of 2, close it up, and I get 1834.990141. Now, I can tell you, this is one of the most missed problems, whether it's in the homework or on the test, and the reason is because people don't follow the directions. It says, round your answer to the nearest 100 years. Well, that would be right there, and that would round down. So the answer would be 1,800 years. So read and follow the directions. We okay with that one? I'll take,
Yes.
good. Okay. What else?
I
Anybody?
have a question.
Okay.
I have a question on 11.
Wait, can't hear you. Yesenia, speak up. What?
11.7, number 12.
Okay. Just a second. Let me find. 0.7. You said 11.7, number 12, right?
Yes.
Okay. All right. An isotope of lead, which is 201 subscript Pb, has a half-life of 8.4 hours. How many hours ago was there 50% more of the substance? So this is that tricky thing where we're going into the past. So we're going to use the formula. A equals A sub 0, 2 to the negative T over H. We know the half-life is 8.4 hours. How many hours ago, that's the unknown, was there 50% more of the substance? So in this case, the final amount, the final amount is given as A. How many hours ago was there 50% more than A? So if this is 100% of A, 150% of A, or 1.5A. So in other words, the initial amount was 1.5 times the final amount because it contained 50% more than it does at the end. You all right with that? Okay, so A equals 1.5 A times 2 to the negative T over H. Whoops, I should be filling, let's see, 8.4 power. I'm going to divide both sides by 1.5A. So on the right side, I get 2 to the negative T over 8.4. On the left side, I get 1 over 1.5. Okay. So now I've got log base 2 of 1 over 1.5 equals negative T over 8.4. I'm going to multiply both sides by negative 8.4. The 8.4s and the double negative go, so I've got T left on the right. I'm going to flip the equation around. T equals negative 8.4. I'm going to use the change of base formula, log of 1 divided by 1.5 or the log of 2. So now I get negative 8.4 log of 1 divided by 1.5, close it up, divided by the log of 2, close it up, and I get 4.91368, etc. It says to 1 decimal place, the 1 rounds down, so 4.9 hours. Okay with that?
Yes.
All right. Anything else in that assignment that you want? I guess not.
No.
Okay. So what else? Anybody? Any more questions? All right. Well, if there's no more questions, then we'll stop the recording. Just a reminder that the test is today. You have until 11:59 p.m. to finish it. Starting tomorrow, we'll be doing reviewing for the final. Tomorrow, we'll look at the first 2 tests, Thursday, the second 2 tests, and then Monday, the last 2 tests. And then on Tuesday, you'll take your final exam. Okay. All righty. Well, I'm going to stop the recording and we'll see you tomorrow. Good luck with your test.